Rectangle N has an area of 5 square units. James drew a scaled version of rectangle N and labeled it rectangle P. What scale factor did James use to go from rectangle N to rectangle P? And first, you need to know what a scale factor is. Now, a scale factor is basically, scaling something, a geometric shape. For example, if you had some shape, like, say we have a rectangle, and the rectangle is 2 by 4. And then we used a scale factor of, let's say, 3. Well, that means that we're scaling up all sides, or both sides of this shape, our geometric shape, up by 3. Or we can think of it as multiplying everything by 3. Which means we're scaling up all of the side lengths by 3 times. Well, 3 times 2. So we have a rectangle that's 6 by 3 times 4. 12. A big rectangle. So then this is what happens when you use a scale factor of 3. And of course, if you want to scale down, so you don't want such a big rectangle and you want to scale down a little bit, well then you don't have to do like negative scale, since, well then you could just do, say I want a scale factor of 1/2. Well then the same thing is, you're going to take all these sides and then you're going to scale them by 1/2, or multiply all sides by 1/2. And, well then that means that you'll get a 1 by 2 rectangle. Since all the sides are just scaled down, scaled down by 1/2. Now the same thing can happen here, right? But here's the problem: rectangle has an area of 5 square units. Well, then first of all, if they're talking about area, then you can't compare area to lengths as we have here. So I'll calculate the area. So the area of this shape, this geometric shape, is 5 times 9. Is 45 square units. So, that means the area from rectangle N, then you start with rectangle N, and then in the end, you're going to rectangle P, it has an area of 45. Well, then that seems like, okay, area of 5 square units, and then we scaled up by 9 times, which means our scale factor should be 9. But actually, the problem is that this is area, and area is a little different than side lengths. Since, if the area is going up by 9, instead of using 9, let's think of something else. Let's say I use the same 2 by 4 rectangle as before. And then we're scaled up by a factor of 2. Well, then I get a 4 by 8 rectangle. But look what happens. After we do that scaling, what really happens now is, first of all, this is 2 and 4. Which means really, after we do the scaling, then there's 4 of these little identical little rectangles, which means, then the area really went up by 4 times. Now that doesn't just work with 2, but what if you tried something else? Like, say I started with a 2 by 2, then the same thing won't happen, right? If I cut all these like that, when we get a whole bunch of these little identical rectangles, which means, if the area is going up by some number, then that means basically, if the area goes up by some number, that means, the side length scaling is because of side lengths, which means both of the side lengths are going to go out, which means the scale factor, since we can only have one scale factor in a shape, the scale factor is going to be, the area is going to go up by 2, by that scale factor squared, since, there's now 2 times, and then all those go together, and then that means, you have the scale factor squared is what the area really is when you use a scale factor, which means really the scale factor you used here is, Well, then if the area went up by 9 times, well, then that means in that little shape, in that little rectangle N, we had to go up or use a scale factor of 3 to get to the side lengths of 5 and 9, which make an area of 45, which means our real answer here is actually 3.